Typically in science, we use the SI units of measure. This is also known as the metric system. The base units that we use most often in general chemistry include meters, which we use to measure a length or a distance. This is abbreviated as M. Mass in kilograms, kg, and then time in seconds, abbreviated as S. There are other base units, but these are the three we use most often. We can also use these base units to come up with derived units. Some of the ones we use are volume, which can be measured in meters cubed, velocity in meters per second, and density in kilograms per meter cubed. Now, these are the standard units. We can also deal with either smaller or larger measurements by using prefixes. These prefixes allow us to look at these different measurement sizes, and they're based on powers of 10. For instance, centi, abbreviated as C, is the prefix whenever we're talking about dividing by 100. So, for instance, centimeters, 100 centimeters equals 1 meter. So if I take 1 meter and divide it into 100 different sections, that's centimeters. And so 100 centimeters equals 1 meter. We can also look at this and we can say that if we divide both sides by 100, that 1 centimeter equals 0.01 meters. These are two ways to look at centimeters. And we're talking about a really large distance or length, we may use kilometers. Kilometers, which has the prefix kilo, abbreviated as K. This is if we take 1,000 meters and we line those up next to each other, we get a kilometer. And so in the same way, if we talk about and divide both sides by 1,000, we get that 1 meter equals 0.001 kilometers. Or that 1 meter equals 1 times 10 to the minus 3 kilometers. And so we can use these prefixes if we're talking about something very small or something very big. Now, these prefixes are the same for all measurements. So I have on the screen kilometers, which is 1 kilometer is 1,000 meters. But we can also talk about kilograms. 1 kilogram is 1,000 grams. Now, this is a table of a lot of these prefixes, going from things that are very small, femto, abbreviated as F, which is 10 to the minus 15. So if you take 1 second and break that down into 1 times 10 to the 15 individual slices, that's a femtosecond. Okay, so 1 femtosecond equals 1 times 10 to the minus 15 seconds, or 1 times 10 to the 15 femtoseconds equals 1 second. Okay. And you can see, we see also larger ones, and we have things that are larger than 1, and these are things like giga and tera. For instance, a tera is 10 to the 12th. So 1 teragram is 1 times 10 to the 12th grams. Okay? Or 1 times 10 to the negative 12 teragrams equals 1 gram. Now, if you look at this, the top half is all things that are smaller than 1. And on the bottom half is all things that are greater than 1. And on the slide, you can see that these are in femtoseconds and seconds, but the same applies if we're talking about femtometers and meters, because the prefixes are the same for all of them. And now, why do we have so many of these prefixes? Because different applications of science can use either of these very small things. For instance, femtoseconds, most lasers fire on the order of femtoseconds, right? So they only send out a very short pulse. Nano, if we're talking about nanometers, which is 1 times 10 to the negative 9th meters, this is where we get the term nanotechnology. So a lot of things like circuit boards are all being built on nanometer scale. And if we look at the larger sides, things like giga and tera, well, you've heard these when we talk about computer storage, gigabytes and terabytes. This is just a lot of memory in a computer. And then finally, many drug dosages are in milligrams. Right? So if you have a vitamin or if you have some medicine, it'll tell you how many milligrams you're supposed to take per day.